Hi, I'm Shane with rkdrums. We've just completed the 12-pound everything kit, 15-pound max roaster. We just finished the whole build out. Check out one of our previous videos if you're interested in seeing how that's done. The last part we're going to do is install the thermometer, but before we get to that, I want to talk to you about an important thing called the relativity of your thermometer. So we just finished this build. It works great. See how it runs. This guy can do 45 pounds of coffee an hour. But I want to show you a couple of important things first. I'm going to set this down to the side, and then why don't we come up close here and have a look. I'm going to remove these diffusers because they're in the way for right now for my illustration, and then I'm going to put this back in so you can see the burners. And then you can see the drum. So a lot of people ask the question, what temperature do I need to roast at? So one of the things I want to cover here is that the temperature that the beans feel on the inside of this drum can be far different than what this temperature probe reads here outside of the beans. We might roast at 500 or 600 degrees, but inside of this chamber, the beans might be anywhere from 200 to 250 degrees, something like that. So a lot of times people ask the question, well, what temperature do I roast at? Well, it depends. So we use a time-based method, not necessarily a temperature-based method, and I'll explain that in a second. But what we do is we take a relative reading of the chamber temperature, and from that relative chamber temperature, we understand what's happening to the beans. So you see that the beans will be sitting right here. We're talking coffee here in this particular subject, but come on up here and let's have a close look at this. And I want you to follow along with this illustration. This is kind of silly, but it's just a mental exercise. If I put this thermometer down here, these are where the burners are, this is where the fire comes out. These are your burner tube, the fire comes out here. If I were to put the thermometer here, let's just say I could put it on the outside of the grill, but 2 inches above the fire. What would that thermometer read if you had to guess? What, 900 degrees sitting here? I don't know, it doesn't matter really at this point. The point is if this is here reading 900 degrees, does that mean that the beans inside of this drum are feeling 900 degrees? I hope you would say no. The reality is that this is closer to the fire, it's hotter. These beans are going to be feeling something somewhat different, and it's also going to be shielded somewhat by this metal. So, 900 degrees on your thermometer does not mean 900 degrees where the beans are at. Let's flip it around. Let's put it up here in the top of the chamber, way up here above. Way up here, far away from the fire. What would it read up here? Well, I don't know exactly. Heat does rise, certainly, but would we say it's going to be colder than the 900 degrees? Yes. So let's guess at something. Let's say it's 400 degrees up here. If it's 400 degrees up here, does that mean the beans down here are feeling 400 degrees? No. It's going to be a relative reading to that of the beans. So when people say, well, what temperature do I roast at? That's really a question that's a little bit different. What we are looking to do with our time-based roasting methods, if you look at the chart on the website, it's under the roasting guide and it's quick roast profiles. You will see that we have times for first crack and times for second crack. First crack time is when the water on the inside of the coffee bean begins to boil. Boiling is 212 degrees Fahrenheit, if we remember that from the 6th grade. So at 212 degrees Fahrenheit, that water in the bean will begin to start expanding, turning to steam, and when that happens, it explodes out of the bean with a cracking sound, a snapping sound. And that, when we hear that first crack sound, the snapping of those beans, that tells us we're at first crack and that the beans are at 212 degrees. So what we are trying to do is we're trying to find what temperature, relative temperature, that we have on this thermometer that will give us first crack, 212 degrees, on time. That's what we're looking for. So we have temperature suggestions in the charts on the website. Those are only suggestions. They tend to work out for most people, but not for everyone. We have some people that, due to how the heat flows in the grill, if you imagine being at a dinner table and you put your hand over the top of a candle. Here's your candle, and you put your hand over the top, right there over it, you can feel a heat column coming off of that candle. It's very, very hot. You could burn yourself, in fact. But if you slide over here, just 2 inches over, off that candle, it's not hot at all. So we have heat that rises up right off of these candles, right off of this flame, and we have the same thing happening here on the inside of this grill. Here in this grill you have 5 burners, and over the top of each burner you have a heat column rising up. And so if this thermometer probe happens to be sitting in one of those columns of heat, it's going to read quite a bit higher than it would, say, just a few inches to the right or left, where it doesn't feel so hot. So you're going to have a wide variation of temperatures inside of your grill. The question is what temperature do you need in your grill that causes these beans to enter first crack and second crack on time per the charts. So because of the charts, follow the first crack time, follow the second crack time, and find whichever temperature works for you in your grill that dials that first crack in on time. If first crack happens earlier than your chart says, then you're too hot. The whole reaction is happening faster. It's just like boiling water on a stove. If you boil water on a stove, if you want it to boil faster, you put more heat into it. If you want it to boil slower, then you put less heat into it. It's the same thing. We're trying to boil the water in this coffee. So we want it to boil it on time. So we got to find whatever temperature on this thermometer in your grill works to cause this coffee to boil on time and cause first crack on time, and therefore cause second crack on time. We have one person whose thermometer happens to sit in a heat column, and he roasts a small amount of coffee at 700 degrees. And then we have other people that roast it less. But the suggestions that we have on the website work for most people. Just understand that until we get a probe inside the beans, the temperature that we're using is a relative temperature. Start out with the charts that we have, with the temperatures we have on the website, and then raise your burners up and down to cause this coffee to crack on time. That's your goal. So understanding the relativity of your thermometer is very important. What temperature do you roast at? Well, whatever temperature causes your beans to crack on time in your grill for where your thermometer happens to be placed. So, well, stay tuned for the next video. In this next video, we're going to show you how to install this into the grill. It's a part of our assembly, but I did want to cover the relativity of your thermometer in this talk. Thanks so much for tuning in, and we'll see you next time.